You all. Now we are continuing the studies lecture. Of course, we were working on the chapter 10, that is the circles, and in this topic we have discussed the what? General feature of the circle. What are the general feature? We will again revise it. How to define the circle, which is a just collection of the point which are equidistant from a fixed point, right? That was the circle. Then we discussed the terms used in the circle chapter, children, right? Like radius, diameter, chord, secant, tangent. Good morning, Namo. Raj Singh also, good morning. Very good morning to you all, children. We are going to continue the lecture. So, all you just be ready with your NCERT textbook, children. Because meanwhile, you may need the textbook to refer the questions, children. Okay, so the important point which we have already discussed in the circle, which we are, the points which are awaited, that is which we most needed, are the tangent and the secant. And based on the tangent, children, we discussed one theorem, that is the theorem 10.1, which I named in short form, that is the tangent radius theorem, children. Right? What is the tangent radius theorem? Radius always perpendicular to the tangent at the point of contact, children. Right? Radius टेंजेंट पे अपने पॉइंट ऑफ कांटेक्ट पे हमेशा राइट एंगल बनाती है, परपेंडिकुलर होती है, राइट? नाउ बेस्ड ऑन दिस we have to solve the exercise 10.1, and of course this concept will be continued. Yes, Raj Singh, this will be continue to solve the problem on the, yes, see, someone, Raj Singh, you are asking that how the OP is perpendicular to XY. Children, in the previous classes also, especially in 9th class also, you have studied this, कि the point which is shortest distance from the center and is equal to radius is always perpendicular to the tangent, right? See, you are knowing the meaning of tangent. What is the meaning of tangent? A line intersecting the circle, or you can say touching the circle at a single point. वो लाइन जो सर्कल को सिंगल पॉइंट पे टच करती है, राइट? दैट इज द टेंजेंट. एंड सी, इफ यू सी, दैट पॉइंट is the point of the tangent also and the end point of the radius also. Getting? Point P is the point of contact, which is known as the point of contact, is the common to the tangent as well as the radius end point, which is the point of the circle also, circumference point, right? So this always makes a right angle to the tangent. That is already proved. There is no need to prove it. Right, children? And other than the point of contact P, if you take any point on the tangent, its distance from the center will be greater than the radius, right? पॉइंट ऑफ कॉन्टेक्ट P के अलावा अगर आप कोई भी एक्सेप्ट P whatever number of points you will take on the xy, its distance from center will be greater than the radius. That means that will be the exterior part of the circle. So only point P, contact point, is only one of the point, right, which is having at the shortest distance from the center, right? This is the end point of the radius. Okay, so it is always perpendicular. Okay, now see what we have to carry forward. Exercise 10.1. If we see the exercise 10.1, refer the NCERT textbook for the question, children. If we see the first question here, अगर अपन first question यहाँ पे देखते हैं, so see, what does it ask? How many tangent can a circle have? Any one of you? I am waiting for your answer. Yes, children. How many tangent can a circle have? Infinite tangent. Raj Singh, very good. See, if we draw a circle, we are knowing that circle is a collection of the infinite number of points. So from each and every point you can draw a tangent like this, children. Okay, the line touching the circle at a single point. So these are the position of the tangent, children. Right? That means infinite number of point tangent you can draw passing through a circle. Right? So this question number 1 over. Have you understood it? Okay, since it is a collection of infinite number of points, circle is a collection of infinite number of points, so definitely we will get the infinite number of tangent, children. Clear to you all? Now, second question says that, what does the second question says? Look at, it is in the form of the fill in the blanks, children. है ना? The terms which we have already discussed, it is in that form. जो terms अपन ने circle के पहले ही कर चुके हैं, है ना? In the studies lecture. Okay, so same points are there. If you can see the first one, a tangent to a circle intersect it in dash points. So in how many points a tangent, this is question number 2, first part, children, which is in the form of the fill in the blanks. This is a circle and this is a tangent. So see the position of tangent to the circle. How many points this tangent intersect the circle? Any one of you? Yes, children, I am waiting for your answer. At how many points it intersect? Raj Singh, only 1 point. Very good. See the position also you can see, children, here, this. Right? So, first answer for the first fill in the blanks is a tangent to a circle intersect it one and only 1 point. ठीक है, चलो अब अपन दूसरा देखते हैं. अलाइन, तो देखो फर्स्ट का आंसर हो गया ओनली 1 पॉइंट, राइट? ओनली 1 पॉइंट, राइट? फर्स्ट आंसर. ओके, नाउ प्रोसीड टू द सेकेंड वन. व्हाट डज द सेकेंड पॉइंट सेज? यू सी, a line intersecting a circle in 2 points is called A. Yes, Harshit, it is 1 for the first answer, only 1 point. Now proceed to the second question, Harshit. Okay, a line intersecting a certain 2 point is called a secant. Abhinav, very good. it is a secant. If you can see the figure, just I'll draw the figure for you, just for revision purpose. Okay, this is a circle and this is a line which is intersecting the circle at two distinct points. You can see, children, and this line is called the secant. Right? So this is the second answer. So second answer you will put, it is called the secant. Right, children? Now we will proceed to the next question. A circle can have dash parallel tangent at the most. Yes, children. A circle can have dash parallel tangent at the most. Any one of you? Raj Singh, only two. Very good. Yes, of course, it has two. Tangent, I'll show you in the figure also. First, I'll clean this part. Okay, I'm having the space. Okay, so for the third point, I'll draw a circle. Okay. I have to show at most parallel tangent. You will draw like this, children. One of the example I have given, this is L, tangent L and tangent M. So tangent L is parallel to tangent M, children. Okay, so we write here only two tangents. Only two tangents will be parallel at the most. Right, children? Now we proceed to the next question, that is the question number 4. What does the 4 says? The common point of a tangent to a circle, and the circle is called what? Common point of a tangent of a circle and to the circle. Raj Singh, very good. It is the point of contact. Yesterday we have seen this definition. Point of contact definition. This is the point of contact. This point P. This is the center O, OP radius, right? So this P is called the point of contact, which is the common point of the circle as well as the tangent, children. Right? Now, see the next question given to you. First I'll clear all these MCQ part. Okay, fill in the blanks part. Then I'll proceed to the next question. What does the next question says? Just see. You can also meanwhile refer the question number 3 according to your exercise. Question 3 says, first I'll draw the figure according to the question. Given a tangent PQ at a point P of a circle. Third one. So first I'll draw a circle and according to the statement I'll draw the figure. A tangent PQ. Okay, this is the tangent PQ. Okay, of radius 5 centimeter. Join the radius, children, here. This radius is 5 centimeter. Right, children? Meet a line through the center O at a point Q so that OQ is 12 centimeter. Join this. OQ, we get this figure, children. OQ is given 12 centimeter. Right, children? So find the length PQ. According to the question, this is the figure, children. Right? According to the question, this figure you will get. PQ is the tangent, OP is the radius, and OQ is the distance of point Q from the center O. So find the length PQ. So how we work out on this, children? See, simply we write by radius theorem. Okay, this statement you will write by tangent radius theorem. Yes, answer is 119, but you have to work out on this. Okay, Raj Singh. By tangent radius theorem, you will write OP is perpendicular to PQ. This region you have to put. Then only you will get the credit. OP perpendicular to PQ, right? Therefore, in right triangle, OPQ by Pythagoras theorem, that is PT. In short, you can write for the Pythagoras theorem as a PT. So what you will get? PQ square. This is the one of the side square equal to hypotenuse square, that is OQ square, minus radius square, that is OP square. Okay, children? So PQ square is equal to OQ. What is the OQ? 12. So I'll write here 12 square. And what is the OP? 5. So I write here 5 square. So what you will get this? 144 minus 25. Okay, children. So what I'll get here? PQ square is equal to 119. Therefore, PQ is equal to under root 119. So this will be the answer for the MCQ, that is the D part, 119 centimeters. So you will write the answer as a D part. Okay? 119 centimeter is the length of the PQ, children. Right? Now, see this next question. Proceed to the next question. I hope this question is clear to you all, children. If any doubt, you just make a comment on this question. Clear or not? You just first answer me. I am waiting for your answer. Then I will proceed to the next. In next question, what we have to do? We have to read the question carefully and we have to draw the figure. That is the diagram. What does the question say, children, here? See, first I'll clean this part to get the space and then I'll show you the figure for the question number 4, children. Okay? What does this question say, children? Let's see. Draw a circle. So, okay, I am drawing a circle for the question number 4. This is a circle. Okay, with the center O, draw a circle and two lines parallel to a given line such that one is a tangent and the other a secant of the circle. So see, children, you will draw this one line. Okay, this line is called the tangent, children. Okay, and one line, this line is called the secant, children. Okay, this is the secant, and take one more line outside the circle. Okay, I'll name the line as LMN. Okay, so he said draw a circle and two lines parallel to a given line. So given line I'll draw as a L, that one is a tangent and other as a secant. Okay, so tangent, secant, and then one extra line which are parallel to each other, children, right? So now see, this is a very shortest part of the circle, children, okay, which we have completed, and now we proceed to the next part, that is the theorem 10.2, children. What does the theorem 10.2 says to us? The length of tangent drawn from an external point to a circle are equal. So first I'll write the statement for theorem 10.2, children. 10.2. So definitely with this we proceed to the exercise 10.2 after completing this theorem, children. So this is the theorem 10.2, right children? What does this theorem says? This says that the length of tangents, I'll write the length of tangents drawn from an external point, to a circle are equal, children. Okay? So according to the statement, we just draw the figure and we prove it कि how the points yes children, chapter 10 is there. What's his name? Rhs. Yes, Harsh, this chapter is in the exam. Chapter 10, complete chapter you are having. Circle chapter is there, okay? So according to the statement, we draw a circle, right children? We take the two tangents from an external point, we join the radius, and you are knowing tangent radius perpendicular to each other, we take the center O, right? Take the external point as a P, Q point of contact, one point of contact to take as a Q, and another point of contact to take as a R, children, right? Then what you do, you will join this OP. This is the very important theorem, children. You are having only two theorem in this topic, in this chapter. One is theorem 10.1 tangent radius theorem, and another is tangent from exterior point to the circle are equal. And definitely 101% alternate year they are asking this, right children? So now according to the figure you will make the given, children, right? What you will write a given? A circle with center O, and tangents PQ and PR. This is the given. What you have to prove, children, here we write the to prove. This is to prove. Tangents from exterior point to the circle are always equal. That is PQ equal to PR. This we have to prove, children. This is a very, very important theorem, children. Okay? And see, suppose this is 3 marks question. So according to the statement, if you have drawn the diagram, if you make the proper given and to prove, suppose you in short of the time you have not got the time and due to any problem, suppose you have not done the proof, but you completed this much work, children. So definitely you will get 1 marks for this work, children. Okay, so this work is very important. Now we proceed to the proof, children. Look at the proof. See, first we write the same region by tangent radius theorem. In short we can write TH. OQ perpendicular to PQ and OR perpendicular to OQ perpendicular to PQ and OR perpendicular to PR. This is the region by the tangent radius theorem. Okay children, now see what you have to prove. We have to prove PQ is equal to PR. So see children, by joining, okay, and join this part, you can write in construction also, join OP. When you will join the OP children, you will get the two triangles. See, this is the one of the triangle and this is the another triangle. And you are knowing in 9th class you have done congruent triangle, है ना? So to make PQ equal to PR, PQ equal to PR करने के लिए अगर अपन इन दोनों ट्रायंगल को कॉन्ग्रेंट कर दें तो by the CPCT corresponding part of congruent triangle PQ will itself equal to PR children, right? So yes Raj, okay, so we write in triangle. See, whenever we have to prove the congruent triangle or similar triangle, first we have to put the heading ki what we are going to do it, so that we have to write. So we write in, of course, right triangle. So we will write in right triangle OQP and triangle ORP. ठीक है children? See, angle Q, that is angle OQP. OQP is equal to angle ORP. What region you will put? Each angle, you will write here each angle 90 degree, that is by the tangent radius theorem. Then you see, if it is a right angle, Q is right angle, then its opposite side, yani OP, will be what? Hypotenuse. See, same thing you will find in triangle ORP. R is right angle, so its hypotenuse will be what? OP only. So you will write hypotenuse OP is equal to hypotenuse OP children, and what region you will put? Common, है ना? This hypotenuse is common. ठीक है? It is a common side for both the triangle children. It is a common side for both the triangle. Now, what must be the other? If you can see OQ and OR children, they are the radius of same circle. Okay, so right side OQ is equal to side OR. Region you will put radii of same circle children. Radius of same circle. So these are the 3 points which makes triangle OQP congruent to triangle ORP children, and you will put the region what? By right hypotenuse side, that is RHS rule. Okay, by RHS rule the triangle OQP will congruent to the triangle ORP children. So by just giving these 3 points, 3 equal parts, you can say the triangle OQP is congruent to the triangle ORP, right? Yes, it is not necessary, but if you will write, the concept will be more clear children. Simply you can write OP equal to OP Raj, it doesn't matter, okay? But if you are writing hypotenuse OP equal to hypotenuse OP, so the concept is more clear. Of course the mark, it does not make any difference in the marks, weightage, okay? You will get the full weightage, no doubt. But since it is the hypotenuse, you are going to applying the theorem RHS, that is the full form of RHS is right hypotenuse side test. So if we are mentioning each and everything properly, which is the right angle, which is the hypotenuse, and which is the side, particularly in this rule. So that is the better. Okay, but there is no deduction in the marks. You can directly write OP equal to OP, OQ equal to OR. It doesn't matter. Okay, Raj. Now, so by the RHS we got both the triangle congruent. Therefore, we can say OPQ. You want PQ na? This is PQ and this is the PR. Last two vertex P and Q, P and R, corresponding vertex. Okay, so therefore we write PQ is equal to PR, and this was our requirement, that is our proof. And you will put the region this year CPCT. Don't forget to put the region. From where we got this? Corresponding, the full form of CPCT is corresponding part of congruent triangle, children. Okay, so see children, the material which we required to solve the exercise 10.2, only 10 to 12 questions are there in this exercise. Okay children, so these two materials we require, two things we require, yes, that one. Two things only we required. Theorem 10.1, that is the tangent radius theorem, children, and Theorem 10.2, that is the tangent drawn from exterior point to the circle are equal, children, right? So these two things only we require, and definitely some general feature of the circle which you are already aware with those features, and all those things we require to solve the exercise 10.2. Okay children, so in next meeting, that is of course tomorrow is Sunday, after the Sunday, that is on Monday, we will meet again at same timing 11:30, and we start the exercise 10.2, children. Okay, so before that, meanwhile, till time, okay, you prepare these concepts by own, because self practice is important, children. Got it? Yes, Abhinav. I accepted your thank you, and I also thanks to you all those who joined right now, for the live concept. Okay children, so on Monday again we will meet and we start the exercise 10.2. so with these requirement, you remember some extra things also, because we need to solve the problem, and that is the very important exercise. One theorem and one question is compulsory from this topic. Okay children, thank you children, God bless you a lot. Yes Raj, Zoom class, yeah, Zoom class will be continue. Zoom class according to your timetable it will be continue. Okay, and the same material which you are joining in the live class, you will get in your Google Classroom also. Okay, and in Zoom class we will clear the doubt only. Okay, this is the regular class 11:30 for the next topic, which are after the chapter 9 we are continuing the topic. Okay, thank you. God bless you all children.